We want to express 5x squared minus 13x plus 2 over x squared minus 4 times x minus 2 in the form a over x minus 2 plus b over x minus 2 all squared plus c over x plus 2. If we look at x squared minus 4, we might think that this is not a linear factor. X squared minus 4 is a quadratic. However, it's a difference of two squares, and we know that this factorizes to give x minus 2 times x plus 2. If we now look at the original expression, we can rewrite the denominator so that it's x minus 2 all squared, because we have this x minus 2 and this x minus 2 multiplied by the x plus 2. What we have here is a factor which we say is repeated as it appears more than once, and this identifies this as a type 3 partial fraction. So the x minus 2 squared is dealt with as a over x minus 2 plus b over x minus 2 all squared, whereas the linear factor is dealt with in the usual way. So the 5x squared minus 13x plus 2 over x minus 2 all squared times x plus 2 is going to be expressed as a over x minus 2 plus b over x minus 2 all squared. And these first two terms, remember, are how we deal with the repeated factor, plus c over x plus 2. We're going to multiply right through by the whole of this denominator. If we do this to the left, we just get 5x squared minus 13x plus 2. If we now do it to this term, the x minus 2 here will cancel with one of the x minus 2 here, leaving us with a times the other x minus 2 and the x plus 2. If we multiply this term by the denominator, then the x minus 2 squared will cancel with the x minus 2 squared, giving us b times x plus 2. Multiplying this term by all of this means the x plus 2's cancel, leaving us with c times x minus 2 all squared. If we now take x equal to 2, this will make this disappear. 2 minus 2 is 0, so the whole of this will go, and this will also disappear because 2 minus 2 is 0. So we just get left with the term involving b. Put 2 in here, and we get 5 times 4, which is 20. Take away 13 times 2, which is 26. Add 2. This is equal to, remember this disappears, just leaving us with the b, so we get 4b. This is minus 4 is 4b, and therefore b is equal to minus 1. We can also take x equal to minus 2. That will make this disappear, and this disappear. If x is minus 2, we get 5 times 4, which is 20. Take away 13 times minus 2, which is plus 26. plus 2, minus 2 take away 2 is minus 4, and squaring that gives 16. So we have 16 c's. This gives me 48 is 16 times c, and therefore c is equal to 3. There is no other value that we can use that makes everything disappear except the term involving a. We've used x equals 2, and that makes the a and c term disappear, and we've used x equals minus 2, which makes the a and b term disappear. In order to find a, our only remaining constant, we could do one of two things. We could just substitute in any other value of x, and we'll have an equation involving a, b and c, but we know the values of b and c. Or we could compare coefficients. In this case, I'm going to look at the coefficient of x squared. On the left, the coefficient is 5, and on the right, we'll get an x squared from here, multiplied by a, so the coefficient is a. We won't get 1 from this term, but from this term, we'll get an x squared multiplied by c. We already know that c is equal to 3, and therefore a must be equal to 2. So we now have the values of a, b and c, and all we need to do is substitute back in order to get our final answer.